Multiplication of matrices. It's a very important concept. In order to multiply two matrices, the columns of the first must be equal to the rows of second. So we can multiply rows of first multiply columns of the second. R1 C1 R1 C2, then R2 C1 R2 C2, then further R3 C1 R3 C2. This is our required matrix, and the final matrix will have the order rows of first and columns of second. Hello class, today we are going to start our O-level syllabus. This is the first video in the series. The topic is matrices. Today we are going to start our first lesson of O-levels mathematics, that is 4024. This is our 38th number, is the syllabus topic, and we are going to cover up this matrices in today's lesson. We are going to cover all the required syllabus requirements in this matrices in today's lesson. So keep tuned and be attentive. What is a matrix? Matrix consists of any numbers. The numbers can be prime numbers, letters, characters, name of cities, whatever. I have chosen over here 4 prime numbers. In fact, the first 4 prime numbers. I can write these 4 prime numbers in a column array or in a row array, or I can write these 4 numbers in 2 rows. All these 3 formations are known as matrices. Now in matrices we have rows and columns. Horizontal are rows and verticals are columns. So in the first matrix we have 1, 2, 3 and 4 rows, and we have 1 column. So in total we have 4 rows and 1 column. Now let's focus on the second matrix. In the second matrix we have 1 row and we have 1, 2, 3 and 4 columns. So in total we have 1 row and 4 columns. Now let's talk about the third matrix. In the third matrix we have 1, 2. We have 2 rows and we have 1 and 2 columns. So we have in total 2 rows and 2 columns. So after defining this, what is the definition of a matrix? And moreover, we can express the matrix with the help of capital letters. Let's say the first matrix is represented by letter A, second B, and third one is C. Now let's focus on the definition of the matrix. Matrix is a rectangular arrangement of numbers, letters, characters, or anything. A matrix is made up of rows and columns. Now these rows and columns have to fulfill certain conditions. Now let's focus on those 2 conditions. First one is that each row must have equal number of elements. If you focus on the first matrix and the third matrix, in the first matrix A, each row has 1 element. If you focus on the first row, in the first row we have 1 element. In the second, third and fourth, on all the rows we have 1 element. We have only 1 column, and in that we have 4 elements. So it is a matrix. Now in the C part, in the C matrix we have 2 rows. In all the 2 rows we have 2 elements, and in the columns we also have 2 elements. This rule is applied to the columns and to the rows as well. Now we know the definition that matrix is a rectangular arrangement of numbers, letters, characters, or anything. So let's discuss few examples to check out whether we have understood it or not. Let's take the first matrix. In this matrix, we have 3 rows, 1, 2, 3, and 2 columns. Now in the first row, we have 2 elements. In the second row, again we have 2 elements. In the third row, again 2 elements. In the first column, we have 3 elements. And in the second column, we also have 3 elements. So it means in each row, we have 2 elements. In each column, we have 3 elements. So is it a matrix? Yes, you're right. It is a matrix because elements in each row are same and elements in each column, they are also same. Let's discuss another matrix. Here we have 2 rows, 1 column. In the one column, 2 elements. Okay, fine. Now in the rows, each row contains 1 element. So what do you think? Is it a matrix? Yes, you are right. It is a matrix. Let's take another example. Here we have 4 rows. First row has 2 elements, but second has 1. Third again has 2 elements, but the fourth one again has 1 element. So each row does not have equal number of elements. And what about the columns? In the first column we have 4 elements, but on the other hand, in the second column we have just 2 elements. So is it a matrix? No, it is not a matrix. Another example. 3 rows, 2 columns. First column contains 2 and second column contains 3 elements. So condition of the columns does not fulfill. Let's focus on the rows. First row has 2 elements, third row also has 2 elements, but second row has just 1 element. So both conditions are not fulfilled. So is it a matrix? No, not at all. It is again not a matrix. Now, order of a matrix means number of rows and columns in any particular matrix. Now, if you focus on this matrix, we have 1, 2, 3 rows and 1, 2 columns. So how we are going to write this? Order is always equals to rows times columns. That is rows into columns. So here we have 3 rows and 2 columns. So what is the order of this matrix? Order is 3 into 2. This is the order of the first matrix. Second matrix. Here we have 2 rows, 1 column. So what do you think? What is the order of this matrix? Yes, you're right. It is 2 into 1. Third matrix. Here we have 4 rows but 1 column. So the order is 4 into 1. And in the last example, we have 2 rows, 2 columns. So the order would be 2 into 2. Now in all these formations, we have to focus really hard that we should write rows at the first place and columns afterwards. For instance, if I write 2 into 3, this means 2 rows and 3 columns. And if I write 3 into 2, this means 3 rows and 2 columns. So it means we cannot change the positions of rows and columns. They have to be in that order specifically. Now let's discuss some important types of matrices. First one is rectangular matrix. If number of rows and columns are not equal, then that matrix is known as rectangular matrix. For instance, if we have matrix A, here we have 4 rows and 1 column. So it is a rectangular matrix. Let's say we have C matrix. In this matrix we have 3 rows, 2 columns, because the order is 3 into 2. Again, rows and columns are not equal, so it is again a rectangular matrix. Square matrix, as it is obvious from its name, that if the rows and columns are equal, then it is a square matrix. For instance, matrix A is a square matrix because rows and 2's both are 2. Matrix F is also a square matrix because 3 rows, 3 columns. Now let's discuss null matrix. If all the elements are 0, it is a null matrix, and it is usually represented by a capital letter O. For instance, O is equals to 0, 0, 0, 0. Here we have 2 rows and 2 columns. As it is obvious that all elements are 0, we can simply write capital letter O. But the only confusion is, what is the matrix of that order? So we just write down its order next to capital O. For example, if we have matrix O with 3 rows, 2 columns, we can simply write capital O with its order. Now, next one is diagonal matrix. A matrix in which all the elements are 0, but the principal diagonal elements are non-zero. For instance, if you have G matrix, principal diagonal means the diagonal coming from top left to the bottom right. This is known as the principal diagonal. If all the elements in that principal diagonal are non-zero and rest are 0, then that matrix is known as diagonal matrix. Remember, we are talking about the principal diagonal. This is the principal diagonal. If we focus on this matrix, this diagonal is not principal diagonal. So be careful in choosing the diagonal. If it is principal diagonal, only then it is a diagonal matrix, otherwise it is not. Okay, next one is scalar matrix. A square matrix in which all the elements are 0, but the principal diagonal elements are non-zero and they are same as well. It is actually a diagonal matrix in which all the elements are same, whatever their value is, but if those values of the diagonal elements are same, then that diagonal matrix is also known as scalar matrix. Next is identity matrix. A square matrix, again, it is a square matrix in which all the elements are 0, but the principal diagonal, and the principal diagonal elements are equal to 1. If the principal diagonal elements are same, then it is scalar, and if they are same and that value is 1, then that matrix is known as identity. We usually represent identity by capital letter I. It can be of 2 into 2. It can be of 3 into 3 order. Now we know we can add or subtract two matrices if they have same order. Here we have 6 matrices with us. Let's check their order at the first place. The order of matrix A is 3 into 2. For B, 2 into 1. For C, it is 3 into 2. For the matrix D, E, and F, the order is the same. That is 2 into 2, 2 into 2, and 2 into 2. The matrix F is represented by parentheses, while the other 5 matrices are represented by square brackets. These are two ways of representing matrices. Both are equally good. Both are applicable. But we cannot use curly brackets to represent a matrix. Curly brackets are used to represent sets. Now let's come back to our requirement. We have to see whether we can add matrix A with B or not. Now check their order. The requirement is if we want to add or subtract two matrices, their order should be same. Do you have the same order for A and B? No. So is it possible? No, it is not possible because they don't have same order. Now let's check A and C matrix. Do A and C matrix have same order? Is it possible to add them? Yes, it is possible because they have same order. Let's discuss one more possibility. C minus D. Can we subtract C matrix with D? C minus D is possible. Do they have same order or not? Their orders are different. So it means we cannot subtract C with D because they have different order. Okay, what is the method or process of adding two matrices? The method is that we are going to add or subtract the corresponding elements. For instance, if we want to add A and C matrix, first of all we will see whether they have same order or not. Yes, they have same order, 3 rows and 2 columns. Now what is the method? The method is we will add the first element with the first one. What is the first element in matrix A? It is 2. What is the first element in matrix C? It is 4. So we will add 2 with 4. Why it is so? Because 2 is from matrix A, 4 is from matrix C. By adding these we get 6, which is the resultant of the final matrix. That is, this is the element of the final matrix. Similarly, we will add the other corresponding elements. Likewise, 3 plus 1 is 4, 5 plus 11, 5 plus 6 is 11, 4 plus 3 is 7, so on. Now let's discuss another example. Is it possible to subtract E with D? Yes, it is, because they have the same order, 2 cross 2. Now the method and the process is the same. For addition and subtraction, the method is we will subtract the corresponding elements. We will subtract 11 with 4, 16 with 6, and so on. So the subtraction is 11 minus 4 is 7, 4 minus 4, 4 minus 8 is minus 4, and so on. Now one thing you have to notice over here, that what would be the order of the final matrix? The final matrix will have the same order. What is the order of A and C? They have orders 3 into 2. So the order of the final matrix would be 3 into 2. And in E minus D, the order is 2 cross 2, because E and D both have order 2 cross 2. Now next is scalar multiplication of a matrix. Scalar means a numeric value. Whenever a numeric value is being multiplied with a matrix, this means we are going to multiply each element with that scalar number. For instance, here we have 2 being multiplied with the given matrix. So each element of the matrix will be multiplied with 2. So the final answer is 4, 6, 10, 14. We have multiplied each element with 2. For instance, in the next example, if we have scalar multiple 3, So now we are going to multiply each element with 3. So the final answer is 12, 3, 18, 9, 24 and 27. Let's say we have a matrix E. This time it is labeled with some capital letter E, and we have to find 4E. This is the same as we have done before. Now the only difference is this time we are using a capital letter to represent the given matrix. Now 4E means we are going to multiply the whole matrix with a scalar number 4. That is, each element will be multiplied with 4. So this is your final answer for 4E. If we have another matrix of dimension 3 into 3, then if we have to find 5F, this means we are going to multiply each element with 5. Here we have 4 matrices. Now we have to check whether we can multiply matrix A with B. We know the condition. The condition is that the two matrices in discussion must have the following property. That is, the columns of the first matrix must be equal to the rows of the second one. What is the first matrix over here? The first matrix is A. How many columns we have? We have 2 columns for the matrix A. And how many rows we have for the matrix B? They are also 2. They are equal. So it means we can multiply matrix A with B. Why we can multiply? Because columns of matrix A, which is our first matrix, equals to rows of matrix B, which is our second matrix. If it is possible to multiply two matrix A and B, it means that the resultant matrix would have some order. The order of the final matrix is rows of the first matrix. Rows of the first matrix are 3 and columns of the second matrix, which are 1. So we are going to write 3 into 1. It means order of the final matrix A, B would be 3 times 1. Now let's discuss one more example. We have 4 matrices. Is it possible to multiply A with C? Now please try it. The rule is the same. What is that rule? The rule is we are going to see how many columns we have in the first matrix. In the first matrix we have 2 columns. How many rows we have in the second matrix? It is 3. These two values are same or different? These two values are different. So it means the condition is not fulfilled. So is it possible? No, it is not possible. Reason? Columns of A are not equal to rows of C. So we cannot multiply A with C. Now we have 4 matrices. Now let's find out, is it possible to multiply A with D? Now please try it. Think how many columns we have in the first matrix? 2. How many rows we have in the second matrix? 2. These two values are same, is it? Yes, you're right. So it means now we can multiply A with D because the condition is fulfilled. What is the condition? Condition is columns of first matrix, which is A in this case, should be equals to rows of the second matrix, which is D. So what would be the order of the final matrix? That is, what would be the order of AD matrix? Do you remember or you forgot? It is rows of first matrix into columns of second matrix. Now here rows of first matrix 3, columns of second matrix 2. So the order of AD would be 3 into 2. Now, what is the method of multiplying two matrices? The method is rows of the first matrix multiply with the columns of the second one. Let's say we have two matrices A and D. How many columns we have in the first matrix? In the first matrix, the columns are 2. How many rows we have in the second matrix? They are also 2. So yes, we can multiply. This is the condition. This is a prerequisite. Now let's do the process. Method. Method is rows into columns. So rows are picked from the first matrix. So what is the first row? First row is R1, 2, 3. And what is the first column in the second matrix? C1. And what is the second column? It is C2. So what we will do? We will multiply R1 row from the first matrix with C1 column from the second matrix. And what is the method? First element with first plus second with second. So this is our R1 C1. Now we repeat the same process with the second column using the same first row, R1 with C2 as well. So R1 C2. Do we have any other column in the second matrix? The answer is no. So now let's choose the second row of the first matrix, which is 5, 4. Now we are going to multiply R2 with C1. The method is still the same. First element with first, second with second. After that, we multiply R2 with C2. It means the process of R2 is finished. Now let's focus on R3. Now R3 with C1. First element with first, second with second. Then afterwards, R3 with C2. Now we have done all the calculations. Now how we are going to write these? That would be our final matrix. R1s in the first row, R2s in the second, and R3s in the third. The result of the answer R1 in the first row, that is R1 C1, R1 C2. These two answers are in the first row. Similarly, for R2, R2 and R2, these two answers are in the second row. And answers for the R3s will be in the last row, R3. Now let's substitute the values and we have our required matrix AD. Now please look at the final order. Final order is 3 into 2 because the rows in the first matrix are 3 and the columns in the second matrix are 2. So this is your order of final matrix. I know that multiplication process is not that easy. So let's do a couple of more examples so that there is no ambiguity in that. So far we are sure about the rule. The rule is rows of the first matrix into columns of the second one. Let's take another example. AQ. How many columns we have in the first matrix? 2. How many rows we have in the second matrix? There are also 2. It means we are ready to go. We can do the multiplication. Prerequisite solved. So now we have to see how many rows we have. We have 3 rows. So let's focus on the first row of the first matrix at the first place. It is 2, 3. We are going to multiply this first row with column 1 and then afterwards with column 2 and then afterwards with column 3, one by one. So that first thing first. Let's take the first row R1 and the first column 1, 3. First element with first, second with second, So we have R1 C1 result. Let's focus on the second step, R1 with C2. Again, the method is same, first with first, second with second. So we have R1 with C2. Now as we have third column, so we have to repeat the process one more time with the first row, R1 C3. Now what is the second row of the first matrix? It's 5 4. Now we are going to multiply R2 with C1, first element with first, second with second, then R2 C2, then R2 C3. It means row 2 has done its work. Now we are going to use or do the working on the third row of the first matrix. So R3 C1 and then R3 C2 and then R3 with C3. Now we have done all the calculations. So what would be the formula? What would be the final matrix? It would be results of the first row in the first row, results of the second row in the second row, results of the third row in the third row. So now let's substitute the values as we have calculated. This is our final matrix. Now in order to confirm, how many rows we have in the first matrix? 3. How many columns we have in the second matrix? 3. That is supposed to be our final matrix order. Is it so? Yes, it means we have done the right multiplication. I hope now you are quite comfortable with multiplication of matrices. Now let's do two more examples so that there is no confusion whatsoever. Let's consider two matrices Q and A. Let's begin with the condition. How many columns we have in the first matrix? 3. How many rows we have in the second matrix? 3. So it means yes, multiplication is possible. And what would be the order of the final matrix? It would be 2 into 2. So now let's start it. Now in this example, we are not going to do the whole working, the detailed working. The detailed working would be in your mind. So now let's focus on the first row. The first row is 1 5 6. We are going to multiply this with the first column, which is 2 5 6. This is your first row, R1. We are going to multiply R1 with C1. So then afterwards R1 C2. So now let's multiply these and write down in our required matrix directly. So 1 times 2, 5 times 5 plus 6 times 6. First element with first, second with second, and third with third. So we have the result of R1 C1. This is our R1 C1 right in the matrix. Now after that R1 C2, that is first row and the second column. The method is the same. First with first, second with second, third with third. Now R1 has done its duty. Now let's do the working of R2. R2, this is our R2. Now let's multiply R2 with the two columns one by one. So R2 with C1 and then R2 with C2. So R2 C2, again first element with first, second element with second. This is the answer for R2 C1. Then second row and second matrix, second column. So 3 into 3, 8 into 4 and 5 into 7. These are the matrices, and the order of the final matrix, as we have discussed earlier, it should be 2 into 2. Now let's do one more example. Again, multiplication, two matrices. Now it's better if you pause this video, do the multiplication and then reveal the answers. In the first matrix we have 2 columns. In the second matrix we have 2 rows. It means yes, we can do the multiplication. And what would be the order of final matrix? It is going to be 3 into 1. So now let's do it. First row with first column, so R1, C1. Do we have any other column? No. So now let's come back to second row, R2 with C1. Substitute the values. And R3 with C1. That's it. 3 calculations, 3 elements. As it is obvious from the information above, 3 into 1 is going to be the order. Now we are going to discuss what will happen if we multiply any matrix with an identity matrix. As we know in numbers, if I multiply any number with 1, let's say 5 times 1, the answer would be 5. 6 times 1, the answer would be 6. So this means whenever we multiply any number with 1, the answer is that number. Similarly, when we multiply any matrix, let's say matrix A, with the identity matrix, which is usually represented by I, then the result is that matrix. That is, if I multiply A with I, the answer is A. Obviously, you have to keep one thing in mind, that multiplication should be possible. That is, the condition is fulfilled, only then we will be able to do the multiplication. If the multiplication is possible, then that rule applies. Now, in order to understand this, let's do one example. If we have two matrices, X and I as you know is identity, X is our other matrix, 1, 11, 3, 2. First thing first, we have to look at the condition. Columns of the first and the rows of the second are equal. So yes, we can do the multiplication. So now let's do the multiplication. Now, as you have done tons of multiplications, now you are quite comfortable in that. It is first row with first column, again first row with second column, then after that second row with first column, and the second row with second column. Now let's substitute the values. First row with first column, so it is R1, C1 over here, then R1, C2 over here. Now you are quite comfortable in that, how we have done that. And similarly after that, R2, C1, second row with first column, and then finally R2 with C2. You know, first letter with first, second with second. Now do the simple multiplication and addition. As a result, we get this xi equals to 1, 11, 3, 2. And what is that? This is again the matrix X. So what is the rule? The rule is that whenever we multiply any matrix with I, the result is that multiplying matrix, provided multiplication is possible. Determinant of a matrix. It's a very important concept in matrices. It has a very wide range of utility and application. We can calculate determinant of a square matrix only. It has wide range of application. We can use it to find area of a triangle. We can find inverse with the help of this, and we can solve linear equations by finding the determinant. So how we are going to proceed further? If you have a matrix A, then its determinant would be the whole word determinant, or DET capital A abbreviation, or we can write down the matrix A capital A and put two vertical lines around it. Now these two vertical lines means determinant. It seems like a modulus, but this is not modulus. This is the symbol for determinant. If we have a matrix A, then we can write A, the elements may be whatever the elements, we are just writing the alphabets A, B, C, D. Its determinant would be written as two straight lines, and the matrix is represented by the square brackets like this, but in determinant we put those lines straight, vertical. This is the difference between writing a matrix and a determinant. Now the next step is how we are going to calculate it. What is the process? The process is we are going to multiply the principal diagonal elements minus the product of other diagonal, that is A times D minus B times C. After calculation we will get the determinant of a matrix. Now let's discuss one example regarding that. If you have a matrix 4, 6, 8, 5, is it a square matrix? Yes, it is a square matrix because it has two rows and two columns. So what is the rule? First of all, we write down in determinant form. This is the first one. First line is the matrix. Second one is representing the determinant. Now let's calculate this. We multiply the diagonal elements, that is the principal diagonal, then the other diagonal. After solving this, the value of determinant for this matrix A is minus 28. That value can be negative, that can be positive, that can be even 0. If determinant of a matrix is non-zero, then that matrix is known as non-singular matrix. If determinant of a matrix is 0, then that matrix is known as a singular matrix. For example, if we have matrix A, its determinant is minus 28, that value is non-zero. It's a negative value. That value can be negative or positive. If it is not 0, then that matrix is non-singular. So in this case, matrix A is non-singular matrix. Let's discuss another example. Matrix B, it is again a square matrix. Find its determinant. Method is the same. Principal diagonal minus the other diagonal product. The answer is 0. Here the determinant is 0. So matrix B is a singular matrix. Now the next concept is adjoint of a matrix. Adjoint of a matrix is another matrix. We obtain it with the help of the given original matrix. How we can do that? The process is we interchange the positions of the elements in the principal diagonal, and we change the signs of the other diagonal. That is, if you have matrix A, let's say A, B, C, D, then the principal diagonal elements are A, D. We are going to switch them. And the other diagonal elements are B, D. We are going to change their signs. So this is our adjoint matrix. That is, A and D are interchanged. Then the sign of B is changed and sign of C is also changed. Let's do an example in order to understand. If matrix A is 4, 6, 8, 5, adjoint would be interchange 4 with 5 because these are in principal diagonal elements, and change the signs of 6 and 8. They are positive, we change them to negative. So this new matrix is known as adjoint matrix A. Now we are in a position to calculate inverse of a matrix. In order to calculate the inverse of a matrix, we should have determinant of that matrix and adjoint of that matrix. If we have these two informations and provided that determinant is not zero, that is, we can calculate the inverse of a matrix if it is non-singular. Then the formula for the inverse is A inverse equals to 1 over determinant into adjoint of A. Now let's have an example. Matrix A, as we have calculated before, we know its determinant minus 28. We also know its adjoint. Let's substitute these values in the inverse. So substituting the values, this is our inverse matrix. Now 1 over minus 28. We know in maths we don't keep negatives in the denominator. Let's take it in the numerator. We can do one more step. We can divide each element by 28. We can write those values in fraction, or we can further simplify it to decimals. But it is recommended to write it in this form only. Don't do the further calculations, because this form will be helpful in further calculations if required. Now we have calculated matrix inverse and we have the original matrix as well. If it is possible to calculate the inverse of a matrix, that is, if the given matrix is non-singular, then these two rules are applied. That is, when we multiply any matrix with its inverse, or if inverse matrix is multiplied with the original matrix, then the answer is always I. What is I? Identity matrix, which is 1 0 0 1. Let's apply this in our previous calculations. We have the inverse, we have the original matrix, isn't it? Now let's do the multiplication. Now we know the multiplication very well. We know rows into columns. First row of the first matrix, which is 5 minus 6, and first column of the second matrix, it is 4 8. So we do the multiplication as before, first column with first, second with second. So it is R1 C1. If you remember, we have done 4 different questions of multiplications so far. Now after that, row 1 with C2, R1 C2. This is your R1 C2. Now after that, we will take the second row of the first matrix and multiply it with the first column of the second matrix, that is R2 C1. And then after that, R2 with C2, second row with second column of the second matrix. After that, we do the simple calculations. As a result, we have minus 28, 0, 0, and minus 28. Now we divide each value with 28, and multiply by 1 is 1, or we can simply divide each value with minus 28. As a result, we have 1 0 0 1. And what is that? 1 0 0 1. Yes, you are right. This is an identity matrix. What is an identity matrix? It is a square matrix in which all elements are 0, but the diagonal elements are non-zero. I hope that you have fully understood the concept of matrices. Now you do further examples and questions from the textbook. It will be helpful. Try to do some questions from the past papers as well. In this channel, we will be dealing with all the concepts of O and A level mathematics and additional mathematics of O levels and further mathematics of A levels as well. So keep in touch. If you have any suggestions, any queries, anything you want me to do first, or anything you want me to change so that we have a better learning experience over here, please feel free to put your suggestions, comments, or ask any questions you like in the comments below, or you can email me as well. Now we have finished our concept of matrices completely. In O-level series, in one video we will complete the whole topic, but in A-level series the method is little different. We divide it into chunks so that they can understood it easily. But in O levels, we will complete the one video, one lesson. Now, keep learning, keep smiling, and keep coming back to this channel. Till next time, bye bye.